Okay, hey and welcome to example 7, sorry. In this example we're going to go with combustion and the parameters and kind of how to shape our fire a little bit more and kind of what the different parameters do and how to use them. So this exact same setup as before, as example 6, but now we're going to dive deeper into it. So let's go into .NET and let's begin. So everything is similar in here as the last example, nothing really changed. Again, all the documentation is on the side here if you want to read through it, but I'm just going to go over it by mouth and words here. So if we go to the combustion, we need to enable it, obviously. The first slide we see is ignition temperature. This is basically how much temperature is needed for the fuel to ignite. So we can define this as a threshold of when things start to burn and when they are not burning. So let's put it to a pretty high value, which means that the temperature needs to be higher. Let's put it to 4, and we can play it, and we can clearly see nothing is burning. If we now instead put it to 1, things are burning. So it's kind of like you have to define kind of how hot things need to be. In this example, it doesn't work too well because it's a sphere, so the temperature is pretty much linear everywhere. But yeah, so this slider is for defining how hot things need to be. So I'm going to set it to the normal 0.1. The burn rate is how fast the fuel is consumed, which means that if I put it to a really low burn rate, which is, as you can see, the slider goes from 0 to 1. Normally, you can obviously put it higher if you want. Actually, you can't, so never mind. But if you put the burn rate to 0.1, the fuel will burn really slowly, as you can see here. You can barely see any flames coming up. It's only like smoke. If we instead put the burn rate to 1, we are now consuming all the fuel, basically, which means that we will have like this heat fireballs bursting out, which can be cool for what we want. But usually value between 0.7 and 0.9 is where you want to place your values here. But let's put it to default 0.9. If you want to go technical on it, it actually is the amount of fuel to burn per second. So the ratio is, if you have 0.9, means that after 1 second, 90% of your fuel will be burned up. But since we are continuously adding fuel, it won't really matter that much that we are consuming our fuel. The only thing that matters is how fast we are consuming it, kind of, which will define how fast our flames are created. Anyway, fuel inefficiency is basically how much fuel is left after we are removing fuel. So if you want to read what it says controls how much the burned fuel is actually not burnt but kept. 0 means that all the burned fuel is removed from the fuel, while 1 means that no fuel is removed from the fuel field. This doesn't really apply to us either because we are continuously adding fuel, but if we would add fuel with right here in initial fields, we will actually feel it. But it can be kind of cool to define like a little bit higher value here to keep more fuel, which will also make it burst out a little bit more, like that, because we have more fuel to burn, basically. I'm going to keep this at 0.1 as well. The temperature output is basically how much temperature your flames will produce. We can definitely see that they're going to rise up. They're also going to push the smoke way higher. The smoke is going to go faster. The flames is also going to go faster because we have more temperature being outputted, basically. So if we put this to a really low value, let's put it to 0.1. Let's see what it looks like. It looks kind of usual, I guess. Flames are still kind of slow. They're still pushing the smoke up, obviously, because a lot of temperature is produced. But if we put it to something quite high, like 5, let's see what happens. You can see that the flames rise really fast and really straight up, and that's just because of that more temperature is produced, so they will rise higher and they will get more stringy, and this kind of quite cool behavior, to be honest, when you get it simming for a little bit. But yeah, So that's the temperature output, how much temperature we are outputting from our fuel. The gas release is basically a scaling factor to how much fuel we have. A scaling factor controlling how much gas is injected into the locations where the fuel is burned. So basically how much our flames will be pushed outwards from the burn field. So a really high value of this would obviously push the flames way higher and way more outwards, while a lower value would be kind of more small scale and slower. So let's put it to 3. Let's see what it looks like. As you can see, we have really tiny flames, really slowly rising. Can be cool for a quite small-ish fire from far distance. And now let's put it to 33 instead. And let's see what that looks like. We're gonna get a big, almost like an explosion, more like a fireball, but explosion-esque. And also this value is what you want to kind of play with a little bit when you do explosions, because you want a lot of gas to be released in the first couple of frames of an explosion. But yeah, so that's gas release, kind of how much it pushes the temperature and the fuel outwards and the flames. If you read the card here, it says yeah, it basically causes the burning areas to blow outwards because more gas is injected into the simulation. Anyway, we're gonna put it to 15 again. So we all have the base values now. And let's see what that looks like. This is the base values. It's kind of controlled, kind of nice fire. Nothing too special, but yeah. So let's take a look at these other tabs here. We have a couple of sub tabs here. We have flames, we have flame height, where we can actually define a more controlled way of defining how high we actually want our flames to be. So if you start by defining these, we get some kind of nice result. We will realize that we want our flames to be a little bit higher, or maybe a little bit lower, or even a lot lower. We can actually define that quite easily here by just doing like, it's like a multiplier fashion, pretty much. It scales the flames. So if we do, instead of 3, we put it to 1, we can clearly see that our flames will be much smaller. Which is really nice to have like this simple value to just define that. If you want it to be a lot higher, we can put them to 10. Let's see what that looks like. And now they're gonna rise a lot higher. Yeah. Which looks really weird. So usually we want to keep it quite low, I think. But yeah, scale of 3 is pretty good. Here you can define some other things, but these are like a little bit overcourse, so I'll leave it for now, but maybe not future tutorial. In the smoke sub-tab, we can define where we want to emit our smoke. As we can see when we play this, smoke is emitted from cooling areas where the fire is dying out, or when the temperature is cool enough to produce smoke. This doesn't really look that cool because we have smoke going on around here, and it looks kind of weird. It might be physically accurate, but I don't really like it, so therefore I can define that by the heat cutoff. So by the heat cutoff, I can actually set it to a lower value, which means that the temperature actually had to be lower for smoke to be produced. And here we can see that there's not so much smoke anywhere here, but more up here, which gives it a little bit cooler result to me. I can even put it lower. Let's put it 0.05. And now we're only gonna get smoke in the absolute coldest areas, which I think looks really cool, especially for these kind of campfire-y type things, because not so much smoke are produced from small-scale fires, especially not when something that produces smoke is not burning. Anyway, let's put this to the normal value of 0.2. It's just a heat cutoff for the smoke. The gas, temperature, and fuel, we're not gonna go into this right now. We're gonna leave them for now. Then in the shame tab, we're just gonna quickly go over shredding a little bit. So shredding is basically what creates a licking type fires. So if you turn this off, shredding, we still have dissipation and disturbance on. Disturbance, we kind of know what it is. It makes this like small kind of tearing and small scale detail to our things. But shredding, if you turn it off and play it, you can see that our fire will look really boring. It will look like just strings of temperature going upwards. It has a little bit of details here, I guess, in the sides, but nothing too interesting to me. Which means that if we turn on shredding and put it to something quite high, now let's see what happens. As you can see now, this is way too high, right? But we can see a lot of small scale, like cool little detail in there. So if you put shredding to 2, and we go back to combustion, and we put a flame height to some higher value, let's say 7. Let's see what this looks like. I think this might start creating some kind of cool definition to our fire, which means that we will have a lot more detail, a little bit more like things going on. The shredding definitely helps with that. Yeah, as you can see, we have more detail now, and this is the point where we can go in and add some turbulence as well. I'm gonna go add some turbulence like that. Gonna put the swirl size to a 0.8, pulse length to 0.3. Yeah, that should be good. And let's see what that looks like. And now we're definitely starting to get some cool details in there. Keep in mind, we are still simulating in a low res detail, right? We're still simulating pretty low res to make it faster and iterative, but we're getting some quite nice things going on in there. So these values are definitely worth playing around with. These two, shredding and turbulence, disturbance, and the combustion, the height of the flames, and all the things can definitely come up with a really cool looking fire. And I can definitely see that I need to reduce the smoke cutoff heat. Let's play it again. Let's see what's going on. Yeah, but I'm liking it so far. Like, it really looks quite cool. It definitely has some nice character to it. So yeah, that's kind of how you want to play around with just fire and smoke to get some like detailed and nice results out of it. Hopefully I covered most of the things I could think of. Again, I left these 3 because I don't think it's a little bit overcourse. We might do it in season 2 or something like this. I don't know, but yeah. So that's how you create some cool looking fire. Yeah, thank you guys for watching, and see you next tutorial. Bye.